So in this case study today, we're going to look at a patient that's on APRV, and we're in the weaning phase. So we're trying to wean the P high in this ventilator mode. I have some of the reports of the end expiratory lung impedance view that you can see on the PulmoVista 500, as well as end inspiratory trend. So we're going to be looking at the impedance values on end inspiration as well as end expiration. If you want some more basic videos on PulmoVista 500, there's other videos that I've done, so I'm not going to be going into too much explanation about the theory behind electrical impedance tomography. You can view some of the other videos if you like. So in this first slide, this is between 920 and 946, where the P high was initially 30 and then dropped to 26. If we look at the middle square, it says title image reference. So this is where we are starting from, which was the P high of 30. In the title image C, right beside it, we see that they both look quite similar. And that's because there's been pretty much no loss in end inspiratory lung volume at the end of inspiration. If there was significant change between the reference P high of 30 and the control, which is a P high of 26, we would have seen in the upper left side the change between the control and the minus. Down below you'll see that there's a reference and a control, and these can be scrolled anywhere we like. If you look at the yellow, which indicates peak inspiratory pressure, so it's not always, it's sometimes a little off by 1 or so, where it's not indicating the P high, it's indicating actually the peak inspiratory pressure, but you can see that there's no peak value being captured. So this is when we're using it in APRV. So as you can see, we're using this view on the PulmoVista 500 if we are thinking that possibly the patient has a certain amount of inflation, but we might be over distending. It might be time to wean down the pressure. Therefore, this view, end inspiratory trend, is extremely important to give us feedback. Now, if we keep on dropping the pressure and we're still seeing the same amount of end inspiratory inflation, then that's kind of like the equivalent of dropping our pressure control and noticing that either the lung volume improves or remains the same. Therefore, we're getting the same tidal volume with less pressure. And this can be used, and it's obviously more in depth compared to global values. We can actually see the regional distribution of ventilation as we're weaning and give much more accurate details about hyperinflation and in what region. This is the view that we have on the PulmoVista 500 for end expiratory lung impedance. Again, impedance means volume. So if we have a gain in impedance, we're having a gain in volume. If we have a decrease in impedance, we have a decrease in volume. So here we're looking between 938 and 1105, where the P high was dropped from 30 to 26. We see that the bottom of the screen, the reference is placed where the P high was previously at 30, and the control is when I walked into the room. So this is roughly an hour and a half comparing the previous P high of 30 and then the drop, and we're looking at any loss in end expiratory lung volume over time. So we see here that we have a global decrease, okay, of 371 milliliters. Now, how do I get that? If you look at the reference box where all you see the numerical values, the PEEP, the tidal volume, the peak inspiratory pressures, as well as the 4 regions of interest from ventral to dorsal, we can see that over this period of time, we lost impedance by negative 0.82. Now to change that impedance into actual tidal volumes, so we have an idea of volumes, not just these random impedances, we're going to multiply those global impedance values or the regional impedance values by the tidal volume in the global reference. That's why you see on the top negative 0.82 multiplied by the tidal volumes in the global reference. So that would be for the global reference, the tidal volume is 453. So you multiply that by 0.82 and you will get the change, or the change in volume. So when I multiply the 0.82 times the 453 in my reference, I get a global decrease in end expiratory lung volume by 371 mLs. If we look at the specific regions of interest, ROI 1 down to 14, which is region of interest 1 is ventral, then we have 2 mid-ventral, mid-dorsal, as well as dorsal regions. We can get the amount of cc's of air changes that have occurred, and these will always add up to your global reference. So it's saying within the, we have a 371 ml loss at the end expiratory lung volume. But now we'll specifically look where that global value is losing, and we see that in a region 1, the 0.08, the 0.54, the 0.16, and the 0.03, starting with region of interest 1, we can multiply all of these times the global reference tidal volume and get exactly from dorsal to ventral the actual milliliters of change in lung inflation at the end of expiration, or the end expiratory lung volume. So region of 1, the 0.08 is equivalent to 36 mLs. The next one is a decrease of 244 mLs. The mid-dorsal, which is region of interest 3, is 72 ml drop, as well as 13 cc's, 13 mLs, 14 mLs in the dorsal. So we see as we dropped from 30 to 26, having 4 centimeters of H2O less, we're getting a very insignificant amount of loss in our dorsal regions. So we see the majority of the loss is actually in the region of interest 2, which is the mid-ventral. And if we look at the top left of our screen, where it's the change in electrical impedance, the end expiratory lung impedance, when we compare the control to the reference, we see that the majority of that loss is in the orange area in the center, where you see there's some loss in the in the ventral, a significant amount in the region of interest 2, the mid-ventral, some in the mid-dorsal, but we also have some blue that's appearing on each side of region of interest 3 and 4. In this panel, we're looking at 9:44 to 10:44, so 1 hour. Now, the reference is placed when I drop the P high to 26, and basically I'm trending the P high over time. So we went down today from 30, now we're at 26. So I put the reference at 26 and I came back an hour later, and now I'm looking at the trending. I want to know, am I losing any dorsal or mid-dorsal ventilation now that I brought the pressure down, because I don't want to de-recruit. The same applies. We see that looking at the top left, the end expiratory lung volume control minus the reference. So the reference is the same as the control. They're both at 26, but now we're looking, now that we brought the P high from 30 to 26 over time, because the de-recruitment is going to occur very subtly over hours, okay, very long periods. It's not like an immediate loss. So this is a wonderful instrument that we can use here, the electrical impedance tomography, to really look at regional distribution and regional gains and regional losses. So it's very easy to see that over time, we were losing some in the mid-ventral, and it was being redistributed down to the mid-dorsal. And that's why in the region of interest 3, we see 0.20 gain in impedance, and we see that there's a loss, significant loss of 0.73, which we can look and see that orange saturation. This is the numerical value. This is the color saturation that tells us regionally where that 0.73, where we're losing in which region. So we see a loss in the mid-ventral of 326 mLs, a gain in the mid-dorsal of 89, with an overall decrease of 248. So we see here a wonderful example of the distribution of ventilation being redistributed from a more higher ventral, mid-ventral area to a mid-dorsal. Here again, we're back to the end inspiratory lung impedance trends, so end inspiratory trend. So we're looking here at the previous P high of 30 that was at 940, and now we're looking roughly an hour and a half later at 11:08, a P high of 26. And we see that there's no significant change by dropping it from 30, well below the 30 now by 4 units, and there's no significant change in the end inspiratory trend. This is a way of validating the idea that perhaps we were over distending, perhaps we were too high in the pressure setting, and that was making the lung not really compliant. And as we decrease, we're still getting the same amount of inflation. We see a very subtle orange that is lost, and we can notice when we look at the middle box and the right box of your screen from reference to control, we can look right in the center there of the reference. It's a very strong white saturation right in the middle. And then when we look at the control, we can see where that loss was. It's a little bit less intense. And these two are comparing each other, and that's why there's orange there. From that loss of intensity right in the middle, this is what's represented here as orange. Then we're looking here at 9:52. Between 9:52 and 11:52, the P high was further dropped from 26 down to 24, since the patient tolerated very well the P high being dropped from 30 to 26. Here we see a global increase of 344 mLs that is increased in the end expiratory lung volume. And this, if we do the multiplications of the impedance multiplied by the reference tidal volume of 420, we're going to get a gain of 134 mLs in the ventral region, a loss of 17 mLs in the mid-ventral region, a gain of 143 mLs in the mid-dorsal, and another gain in the dorsal regions of 92 mLs. So we see a shift away from the mid areas to the ventral regions and dorsal regions, creating a more homogenized, more homogeneous distribution of ventilation.